Okay, today we're going to be discussing sides and angles of parallelograms, and these are our content standards and the mathematical practices that we'll be using when we do our assignment. So previously you've classified polygons with four sides as quadrilaterals. Now we're going to recognize and apply properties of the sides and angles of parallelograms, and we're going to recognize and apply properties of the diagonals of parallelograms. And our new vocabulary, parallelogram. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. So to name a parallelogram, we use this symbol. So this would be parallelogram JKLM. So we could write that instead of the word parallelogram. The properties of parallelograms are listed in these theorems. So why don't you pause for a moment and make a note of these theorems in your notes. Note the proof of opposite angles of a parallelogram are congruent. Now let's use the properties of parallelograms to find missing measures. In parallelogram ABCD, suppose that the measurement of angle B is 32, CD is 80, and BC is 15. We're to find AD. So you might draw this parallelogram in your notes, sketch that very quickly, and label what you were given. It'll help you as we go through the rest of the slides. So AD is equal to BC because opposite sides of a parallelogram are congruent. BC is 15, therefore AD is also 15 inches. Again, we're given the same parallelogram, the same measures, but this time we're asked to find the measure of angle C. Well, the measure of angle C and angle B is 180. You'll notice that in the sketch that you drew in your notes. The measure of angle B is 32. We are told that, so we know that subtract 32 from 180, so the measurement of angle C is 148. Let's do another. This time we're going to find the measure of angle D. Well, the measure of angle D and the measure of angle B are congruent because opposite angles of a parallelogram are congruent. The measurement of angle B is 32. We're given that, so that is also the measurement of angle D. Time for you to check your progress. So pause for a moment, work the problem, come back and check your answer. Okay, so we know that AB is the same measure as CD because opposite sides of a parallelogram are congruent. So we know that the measure of AB is 30. Another one. Pause for a moment, come back and check. We know that opposite angles are congruent so that we know the measure of angle C has the same measure as angle A. So measure of angle C is 36. Let's do another. The measurement of angle D is supplementary with the measure of angle C. Angle C is 36. So 180 minus 36, the measure of angle D is 144. The diagonals of a parallelogram have special properties as well. So note that if it's a parallelogram, if a quadrilateral is a parallelogram, the diagonals bisect each other. And also, each diagonal separates the parallelogram into two congruent triangles. So let's use these properties to find missing values. We know that WX and ZY are opposite sides and they are congruent. So we could set 4R equal to 18 and solve for R. You might make a note of sketch this in your notes so we don't lose this. Oh, they give it to us again. Good deal. Now we're trying to find the value of S. Okay, so 8S is equal to 7S plus 3. Okay, because diagonals of a parallelogram bisect each other. So we subtract S from both sides, 7S from both sides. S is equal to 3. And another one, we're to find the value of t. Now, a diagonal separates the parallelogram into two congruent triangles. So by corresponding parts of congruent triangles, we know that angle YWX is congruent to WYZ. So we can say 2t is equal to 18 and solve for t. Okay, time for you to check your progress. So pause for a moment and come back and check your answer. Okay, did you set this one up? 4x plus 12 is equal to 6x plus 2, and then solve for x. So we'll have 10 is equal to 2x, so x is equal to 5. And another problem. We know that 2p is equal to 22, so divide both sides by 2, p is equal to 11. We know that 3k plus 4 is equal to 25. Subtract 4 from both sides, divide 21 by 3, and we have 7. You can use theorem 6-7 to determine the coordinates of the intersection of the diagonals of a parallelogram on a coordinate plane given the coordinates of the vertices. This sounds worse than it is. Let's just look and see what everything's in your toolbox that you need to solve this. So we know that the diagonals of a parallelogram bisect each other, and the intersection point is the midpoint of MP, and we know that MP make one segment and NR make the other because of the way it's labeled. So let's find the midpoint of MP. So the midpoint formula, we're going to substitute in the points for M and P into this formula. So our midpoint is 1, 2. So the coordinates of the intersection of the diagonals of a parallelogram, MNPR, are 1, 2. So time for you to experiment with that. I hope you wrote the midpoint formula down. If not, you need to go back and get that in and pause and then come back and check your answer. Did you get 1/2 and 1? I checked L and N. So I get 0 plus 1 divided by 2 and -3 plus 5 divided by 2. So 1/2 1 is the answer. And finally, you can use the properties of parallelograms and their diagonals to write proofs. Oh yes, you thought we were done with proofs, didn't you? Not quite. Parallelogram ABCD is what we're given. AC and BD are the diagonals, and point P is the intersection of AC and BD. We're supposed to prove that AC and BD bisect each other. Okay. So what do we notice here? We're given that ABCD is a parallelogram. We're given that AC and BD are diagonals. Oh, so because they're diagonals in a parallelogram, we can say that AB is parallel to DC. Make a note of that. We didn't know that earlier, except through the theorem. AB is parallel to DC, and AC is the transversal. Okay, so I'm going to let you pause for a moment and read through the rest of this, and then we'll move forward. So, from the notes you took last time, which of the following is relevant information that you're going to need in order to prove that angle LNO is congruent to angle NLM? So I'll let you think on that. Remember the problem we just worked and what stood out to us. Yes, what's relevant is that LM is parallel to NO. Excellent job. Now you're ready to begin your assignment.